Okay, welcome in this second section. Now in this section we're going to talk on how we can create, for example, this gravity well we see over here, using multiple points and also using attributes we generate right over here. So that's the first thing we're going to do, is we're going to start adding some attributes and making sure that we can read those attributes right over here. So an attribute would be the following attribute create. We're going to create two attributes. The first one is going to be the mass, and the second one is going to be the density. The density of the object. So we're going to use some standard values over here. First one has value 1 by default, so that's fine. And this one, the density, we also going to give it a value of 0.5, so something in between. So now we're getting this information right over here. It's stored on this point. We can see them right over here. And so we're gonna get them right in here in our VOPSOP. So let's move on. And so the things we need to do is we need to replace actually these two inputs. So the density and the mass. Now you've seen before that you can get attributes using over here, using an import attribute. So you need to use exactly the same thing actually. So if you think you can solve it right now, try to solve it by just making sure that you replace the inputs we see over here and that you replace them actually with the attribute imports. If you didn't succeed, I'll show it to you right now. So I'm just going to copy this, and the nice thing is it's automatically connected to our constant, the constant which is being number 0 still. So this one is going to be dense for our density, and it's not a vector attribute, so that's really important that you change it into a float, change it into what it really is. So we can replace it just over here. I'm just going to remove our density right here. I'm also going to move this one more to the back. So always make sure that your graphs are nicely organized, that you can see this flow. Avoid as much as possible wires going backwards and forwards. So I'm going to copy this one as well, move it up here, and this one is going to be our mass. And we're going to connect it over here. So right now this should work. So if we go right here, we see mass, and if we go right here, we have a value, the density, and this one is called position. Well, it's also good to give these ones color coding, again, that you can see very quickly which ones are being used over here. I'm gonna use a different kind of color coding for those, perhaps something like this, blue. So the blue ones are like the importing of attributes. Okay, so this should work. Now there's one thing with the density, what we see over here with the density. Remember that we only allowed for values between 0.01 and so on. So what we're going to do right here is we're going to clamp those values so that we never have like some overshooting. So if you use a clamping node, the minimum and the maximum, and then we can clamp it to 0.0001, something like this, and this one is going to be 0.9999, something like this. Okay, so if we go right up now and check our VOPSOP, I would expect to see something, and we do see something. It's very vague, and the reason most probably is that our density is not high enough, so we're going to increase the density, as you can see over here, and we can of course change the mass. So right now everything is being controlled, as we can see right over here. using an attribute. So in the meantime you can also start, for example, changing the density over time. So let's take a sine, for example, $f, and you know the sinus wave goes from minus to plus 1, so I'm going to multiply it by a half, and on top of that I'm going to add a half. So this is going to bring it nicely in between those values. And so here we see the density going from very dense to no density at all, and so on. Okay, so this seems to work very nicely. 0.7, I'm gonna give it something like this. So now this is again our gravity well. So the next step now is we need to try and create like multiple points, because now we've added over here our attribute in the attribute create. Now suppose if we have like multiple planets, and so for that I'm going to create like a circle, and let's see, I'm gonna put this circle right on the ground, make it a little bit bigger, like we can see right over here, and we use a scatter, tap scatter. Now there's way too many points, but if we start off with, let's say, something like 20 points, then we only see 1 point over here, and that's exactly not what we need. So if you see over here, we will find point 0 somewhere right here, and if you look at that, it's really point 0 that is affecting the whole thing. Oh yeah, of course, it's not that clear because of the transform node in between. So if you see that here, more or less over here, we should have point 0, and that's indeed where we find point 0. So now we have to do exactly the same thing, but for all points. So I go over here. So in order to do this for all points, we need to figure out how we can adjust these values within a for loop. So we need to evaluate all of those points of the second input. So how can we do this? Well, we need to get like this number of points, and we can't get that right over here, the total number of points. So npt, which is an integer, I don't think it's going to be given to us by default, so let's try that first. So let's say that we import again an attribute which has like this constant, and npt, we have this as a value, and it is an integer value. So let's check whether this is going to return us something, and we can do that by adding an attribute and connecting the attribute over here. So let's give that attribute a name. As you can see, I've used over here some expressions to automatically add all these things, so I just have to set a proper name over here by adding an attribute, and let's say number of points, something like that. So if you go up, see, number of points is 0, so that doesn't work. So let's go back inside. We can just remove this. So we have to do it another way. So how can we do that? Well, we're going to add just a parameter. So I'm going to place a parameter over here, and in this parameter we're gonna get an integer value. That integer value is going to give us the number, the total number of points we're dealing with. So that's the first thing we need to get. So again, I used over here something to automatically name everything, and this is number of points that needs to be evaluated. Now it's another color, so change it to the right type, which is an integer, as we can see over here. So how can we get this? Now we see right over here number of points. So I'm going to add like a null node, which is going to make it easy for us. So again, good practice that you can always change something. Use the expression number of points, and we're going to get this from the null one. Okay, so if you middle mouse button click over here, or if you just click on this one, middle mouse button clicking is if you want to see an evaluation of an expression over here. If you just click, then you see what the result is, 20 points. Okay, so that's exactly what we need. Now we're going to create a for loop, and in this for loop we're going to make sure that we can do this whole operation we've done before on each of the points. So what we need to do is we need to collect the complete distortion. So we see that over here, the value for the ramp parameter. So we need to have like two outputs. It's this negative value for this, or perhaps we can leave it just over here. We can just end it at a divide, and we'll just use it that way. That's even better. So we just have one output, the divide, and this is going to be the collective gravity. So that's the input parameter. We're going to set a constant, which is the gravity, and make sure to also name everything on the inside over here. So it's actually best to do this kind of expressions on the inside as well, right over here. So again, it's very easy for you to set just one name. So what I'm going to do right here is I'm going to save this as permanent defaults, and like that it's going to be very easy for me to do it next time. So I have two of these. So the number of points, that's the first thing that we need to connect to our for loop. Well, a for loop works exactly the same as other for loops. So we have like an initial value, which is 0. So it starts off counting from 0, and it has an end value, by now set default as 10, and then an integer step size. That is how it starts to count, which kind of steps it's going to use in order to count until it comes to 10. And the test is the value needs to be less than 10. The moment it's equal to 10, it's going to stop. It's not going to evaluate anymore. So the first one is going to be 0, counts up to 9, and then stops. So we have 10 iterations overall. So now we're going to do this for the number of points. Now take a close look what's over here. We have an integer with another integer. Each parameter bound is going to give you just a true and false value. Just hover over it, and it's going to say, okay, is this really working? So we're going to use this one, end value. And the gravity, well, the thing what we need to do is we're going to calculate the gravity for each point. So it's something we see right over here, this whole thing. And we need to make sure that everything is getting collected, is going to be added to each other. So we have to start off with also over here an initial gravity value, which is 0 at the start. So like this. So we have two inputs. Okay, so now what we can do is we can take this whole graph we see right over here, and what we're going to do is we're going to cut it. So press Ctrl X, and we're going to paste it right over here on the inside. Okay, so we have two things, with the input and the output we see right over here. So the constant is that one point, the 0 value that we have over here, to say, okay, if we want to calculate the density, we want to have it from point 0. This is not what we want right now. Now we want it to be evaluated for each one of those points. So in this for loop, you have this initial value, this end value, and this step size. Now the end value is being connected on the other side. Now the special thing about the initial value within the for loop, and so right now we're within the for loop, is that for each iteration it's going to give you the number of the current iteration. So it starts off with 0, then you get like a value 1 for the next iteration, value 2 for the second iteration, and so on. So this is exactly what we need to connect. So connect it over here and go right to that place. Right here as well. And over here as well. Okay, so this constant node is something we can remove already. So that's done. Then there's another thing. As we can see over here, we have our distance node and one port is not connected. It's missing something. Well, the thing we did before was that we had a connection with the point position. Now we need to get that point position on the inside back again. So we're gonna take the point position, take this point position, and also connect it over here with this distance. So this way we have the distance being calculated for each one of those incoming points with the current point. So we're almost there. So now we need to connect our gravity. Now what I said is we need to be able to collect this gravity over all those iterations. Now what we see over here is we see in the for loop the input port and the output port, and both of them are available. So what we're going to do is over here we're going to take the gravity, we're going to add to this gravity our distance, the divided distance that we see. And we're going to put this back into gravity itself as an output. So what's going to happen is that in the first iteration we get this initial value, this gravity, which goes in, and the initial value of this gravity is 0. It goes in, comes right over here, we add the gravity of the first point to it, it's being stored again for the first iteration, so we have this gravity, and it comes back out of here again, and that first gravity is going to have like the second gravity added to it, and then both of those gravities are being stored again, and so on and so forth. So now that we have this, we can move everything a little bit closer together. The only thing we need to do now is to just connect our gravities over here and right over here with the multiply. And so now if we're gonna look up and we see our VOPs up, of course without this, we see our gravity well, of course with all these points, and they seem to weigh quite a lot, we see like this heavy distortion. So what we're gonna do is we're gonna change the value of our gravity. Let's make them a little bit lighter, and as you can see, this is how they are all distorting the whole thing. So you can now very easily create, for example, random $pt times, let's say 2 or something like that. So now we have like different points with different gravities, and we can do exactly the same over here, something with densities, so we have things with different density as well, and gonna have like all kinds of different shapes and points. So this thing right now is going to give us a distortion of our space fabric as we can see it, and it's distorting the whole thing very nicely. Okay, so what we're going to do right now is we're gonna make over here our planets a little bit visible. And so we have to take into account their mass and density. Now how we can do this is by doing the following. So if we go over here, we see we have two of these attributes being generated. Now we can only use a new attribute create in order to make sure that we can use the attributes we've created above. So what we're going to do is the following. We're going to take the mass and we're going to divide the mass by its density. That's the first step. It's not going to be all, of course. And we're going to do this in order to create a p-scale attribute. Now this is one of those standard attributes that you can use in Houdini. So if you use now a copy node, and we're going to have like a sphere over here, then we can control the size of those spheres by this p-scale attribute. As you can see over here, they're like very big right now. How can you find out of those things? Now let's go back to the help file. Come on, help. Oh yeah, I've put it right over here, so it's right in my browser. So you see the copy surface node. Now if you go down, it says something about instancing and so on. The instancing point attributes. Also, this works both for copying as well as for instancing. So when you copy or instance geometry onto points, Houdini looks for specific attributes on the destination points to customize each copy instance. So if you go over here, see like several of them. So the normal and the up, these two in combination, that's something you use to orient your geometry. But here you see like these other ones, p-scale, which is uniform scale, or scale, which gives you a float 3 non-uniform scale. And there are many other ones, so you can also use rod instead of the other thing. Takes in a quaternion or orient. And here you can also override, for example, material and the kind of material the node is going to have. Material override is, for example, if you have a material that you can change the color. But those are things for later or for you to research on how to do this. But here we see exactly that kind of attribute that I'm talking about. Okay, so now we have this, but still everything is way too big, especially if we compare this to what we have right here. So we need to adjust this. Well, there are a few things we need to do as well over here. So mass divided by density, and we can do, of course, times 0.1, something like that, and then everything becomes like much smaller. But it's still not really okay, not exactly what we need. Now you're also gonna see if we're gonna bring this together in a merge node. If you work with all those points at the same time, it's kind of hard to distinguish or to see what's really going on. So we need to make sure that we can understand what's happening right over here. So we're going to bring this down to just one point, and here we see how it's being represented. So what we're gonna do as well is the attribute create we have over here, we're going to copy and paste this so that we have two versions of that, the original and a new one, and here we can really set our values. So let's see what's happening. If I move this down, okay, then I get to like this really small value, and then suddenly it becomes like really big, but this is not at all what we need. I mean, this object already shouldn't have like almost any density. Let's add some more gravity to it that we can clearly see what's going on. but as you can see, the object should be way bigger right now. Now of course you can start to play over here with say, okay, let's tweak this until we have like a little bit a bigger value, but still this is not going to work in the end, because if we're going to reduce the size, it's still not big enough, and especially if we compare it with this. Yeah, it grows somewhat. Well, perhaps this matches in part what we need. We can get it to very small. The only thing is, when it's set to 1, we should have right over here already a value which is like infinitely small. So what we can do right over here is perhaps we can also multiply it with what we have right over here, and that is the density. Or better to say, the inverse of the density. 1 minus density. So something like this. Okay, so now our point is infinitely small, and it can grow bigger until this, but then it doesn't grow like really big. So we need to do something else over here. How can we do this? Let's say if we divide 1 by its density. Again, this is not going to work exactly. We're going to do exactly the same thing. Minus $dens. And so now we're gonna have like this quadratic growth. As you can see. To infinitely big. So we're just applying exactly the same thing like we did before. So we took the mass and the density, we had like a multiplier value to set everything right, and then we did exactly what we have right over here on the insides. So it's taking the density, inverting it, and also subtracting the whole thing. So the only thing we need to do is, because we have these densities, we need to clamp those densities that we don't leave, like overshooting values. Clamp density, comma 0.0001, comma 0.9999. Let's use this, copy paste it. You can paste it over here, paste it over here as well, and voila, here we have our system ready. So now we can just easily connect it right over here, set it to a multitude of points. We have like 20 points, and so as we can see, we have some of them which are like very big, other ones which are very small and very sharp, and even like extremely big shapes. So this shows everything for our density and what we have. Now our density, let's bias this a little bit more, or let's fit this more to something which looks a little bit better. So fit 01, Now we have 0.5 to 1, something like this. And so here we see like different kind of densities of bodies all acting together. Alright, so this concludes this part of the lecture. In the next lecture what we're gonna see is how we can create like this whole gravity simulation, and that we have like the animation and everything on top of that. So I'm gonna pause this right now, or I'm going to stop this right now, and you can see the rest in the next lecture.